Hi guys, in this video I'm going to go over some of the concepts and strategies that you want to use if you're teaching mathematics to students. Some of this is kind of a conjunction of education theory and as far as learning theory, developmental psychology, some different things that are thrown together, but this is kind of, in a nutshell, information on math pedagogy and what you should be doing with it. Okay, so the first thing I want to talk about is the idea of conceptual versus procedural knowledge. Now, this idea of conceptual versus procedural knowledge is best illustrated with an example. A conceptual knowledge of something is being able to do it and know why it is that way and be able to figure it out if you can't remember the process exactly. Okay, so I often gave and have given in the past the following analogy. So I play a little bit of bass guitar. Not well, but I do a little bit. And what I do is I just pull up tabs online, I find songs that I like, and I learn the tabs. I don't know anything about reading music other than like sitting down and like figuring out where the notes are. Okay. I can't, other than that, I can't read music. Don't understand music notation. Don't understand the process or a theoretical background behind, when that particular instrument should be used, what kind of notes should be played, all that kind of stuff. My understanding of playing bass guitar is strictly procedural. I can do something if you show me what to do, but beyond that, forget it. I would be terrible in a band, okay? Because I don't understand how that stuff fits together. So I don't have any conceptual understanding of playing that instrument. My brother has been playing since he was about 15. He's done it for years. He's played with people. He's played without people. He can do anything. In other words, when he comes to my house, a lot of times he'll pick it up and plunk around. He'll say, "You should be doing something like this," and he'll improv, and I'll just look at him like, "Are you crazy? I don't know enough to do that." But sometimes people with a deep knowledge of a particular subject have trouble conveying that or understanding that other people are coming from different directions. So conceptual knowledge or conceptual understanding is that deep, rooted, I get it. This makes sense. I know what it is. I'm good. Versus procedural, which is the kind of information and the kind of learning that most students get in a math class. Most students in a math class are only taught how to do a certain process, how to multiply two-digit numbers, how to factor an equation, how to calculate the area of an irregular shape, those kinds of things. The problem with that is if they don't encounter that particular kind of problem exactly the way it is, then they can't figure it out because they don't have a background for understanding it. So think about that for a minute. Circumstances for a procedural learner, circumstances have to always be identical or they don't know what to do. They can't adapt. Conceptual learners or someone who has learned in a conceptual way can adapt, because their learning was not restricted to very particular conditions. Their learning was approached from a broad process of understanding why something happens and where it comes from, so that when they are encountering a new situation or a new problem, they can look at it and they can say, okay, I don't remember doing one like this before, but it looks like this. And they're able to kind of work through that process of problem solving, trial and error to figure out what it is. Not only that, but somebody who has a deep conceptual understanding doesn't need to remember processes because they can refigure out the process every time. Refigure. I don't think that's an actual word, but it works. So if I don't remember the exact steps for multiplication, for example, that's okay because I understand the concept of multiplication. So if I don't know what 4 times 5 is right off the top of my head, that's okay, because I know that if I write down 4 things in groups of 5, I can figure it out. That's another example. Okay, so we want to teach students from a conceptual perspective. We don't want to just teach them processes. We want to teach them why we do the things that we do and make sure they understand why we do things a certain way. All right. In order to do that, we have to always start with something that they know and understand. So we have to start with what is already there, which is prior knowledge. Okay? You've got a lot of educational theorists that you have hopefully learned about through the process of your studies. One educational theory is that of constructivism, where students build their own knowledge. They take things, they put them together, and they construct their own schemas based on what they have learned and how they have put that together. So they're allowed to put it together however they want. But the information is given them. They are given the opportunity to build this knowledge base. So an example I like to use for that is Legos, because they're great building things, right? So if you've got, you see the bottom of this Lego house, you've got this thin green plate, and you can get these things, of course, in various sizes and various colors and things like that. Now, if you think about this, you could build this house without that, all right? But it wouldn't be as solid. It wouldn't be as durable. It might fall apart, and it would be tougher. You can maybe do it, but it would be a lot tougher, okay? But with this foundational piece, it makes it super easy. Building prior knowledge in students works the same way. Students need some kind of a foundational piece. All of them have one somewhere. You have to figure out what it is. Maybe it's a math concept that they've already learned and they already know, and you know they know it. Maybe it's something that doesn't have anything to do with math. Maybe it's something that relates to everyday life. Like the example that I gave you with the bass guitar. Okay, you all know what a bass guitar is at the most fundamental level. So that's all I needed to provide you with that example. The example with the math problem, 4 times 5. All of you know what 4 times 5 is. So I started with a concept that you know. So activating that prior knowledge. Bring it up when you go to teach a new concept. Always start with something they know. It helps to warm them up, but it also sets the foundation for what you're going to teach them and how it relates to what they already know. Okay. So building prior knowledge and building that foundation. Now there's another piece to constructivism called social constructivism, where in the social aspect of having conversations is important in developing knowledge and understanding as well. And I'll come back to that piece a little bit later. So procedural versus conceptual knowledge, activating prior knowledge, all right, and building a foundation for students to learn. Another piece is moving from concrete to abstract. The single worst thing I have seen in math instruction is doing the following. Starting with a concept that even maybe isn't all that complicated, like equivalent fractions, and teaching it from the abstract perspective right off the bat. It makes no sense whatsoever. If I were to sit and describe to you something, for example, I've got this thing on my desk. It's round, it's blue, it's got some flowers on it. It's kind of hollow in the middle. You might not have any clue what I'm talking about. But if I were to show you, hey, look, I've got this candle holder. It's round, it's blue, it's got flowers on it. It makes sense, okay? Do not ever, if you can avoid it, with higher level classes, this is hard and sometimes impossible. But with lower level classes, there's no excuse. Do not ever start teaching a new concept without starting students at the concrete level. Give them something, a thing. Not just a picture of a thing. Give them a thing, okay? If you're doing fractions, give them something that they can tear up into fractions or cut up into fractions. Give them fraction pieces. You can use paper. You can use blocks like Legos. You can use anything, almost, all right? Start with something concrete. Make sure they understand what this thing is. Then slowly move them from, okay, we're gonna go from this, the three-dimensional object, to a drawing, okay, to a representation on paper. Now here's what this looks like. Then move them from that to the abstract, which is just using numbers to represent it. Here's an illustration for you, okay? Let me take my Legos again here. I want to take apart my little table. And yes, I said it's my house. Okay, so I've got my little Lego piece here, and I can see that it's a 4x4, right? So if I look at this and I divided that up and called those fraction amounts, right? Then I could divide that up into 16ths. So if I were to cover up 2 of those, all right, now I have how many 16ths? Something like that. Then I would, after doing that process, I would move to having students draw this picture and then write the number underneath the picture. So here, I would have them write, these are n/16ths. Then I would have them draw the picture that would represent it and say, okay, now that 2 are gone, we have this many 16ths. That kind of thing. What you want to do is you want to associate visuals with the numbers. One of the reasons why kids struggle in math is because they're never allowed to do that. They are solely given the numbers, and developmentally speaking, they can't handle it. They can't do that. Not only the fact that most learners are visual, and so if you don't give them visuals, they're not going to learn the abstract. So don't ever do that. Like I have told students before in my Math for Elementary Teachers courses, if I ever see you teaching equivalent fractions without visuals and moving them just straight to the abstract, I will haunt you because it is a disaster. Fractions are one of the biggest areas that people freak out about, and that's why. That's totally why. Because all that they have to do is hear that word and they go, oh my gosh. Well, it's because probably at some point in time they had a teacher who was uncomfortable with it and didn't do a very good job teaching it, and then that has just grown exponentially. Okay. So if you've got a teacher who has 20 kids in a class and they teach for 20 years, that's 400 students now who can't do fractions. Think about that. So you have an obligation to make sure you can teach all of your content to the best of your ability. So pictures, right? So start with objects, go to pictures associated with numbers, then just the numbers. That's how you move students from concrete to abstract. Now, like I said, with advanced level content, it's hard to do. You know, it's a little bit hard to do with calculus. It's a little bit hard to do with algebra. But there are some ways that you can incorporate some of those processes in there. So give them a try. Doesn't mean you have to do every single lesson that way. What it means is when you introduce a new concept, a new unit, a new theme, you need to do that to provide them with that progression. Okay? So concrete to abstract. Going along with this, and the last in terms of identifying different needs and developmental levels in your class and thinking about how to work through the learning process. Keep this in mind, and that is ZPD, which you should know and be able to remember by now, referring to the zone of proximal development. So if you can remember in your head, I'm making you do the abstract now. If you remember in your head, right, that little grid where you've got 4 quadrants, if the information is too easy, kids get bored. If the information is too hard, well, in association with support too. And if the information is too hard and they don't have enough support, then they get frustrated and they give up. They get emotional. If you've got this perfect combination of difficult material, the right level of difficulty, and the right level of support, then students are challenged to move just beyond what they know. We want to stretch them beyond what they know, because if we don't, they're not learning and growing. So we want to get them just above that a little bit. Sometimes it's hard, sometimes it's strenuous, sometimes it's taxing, but we can get them there. And what you need to do is to keep in mind that term productive struggle. My 3rd grader came home one day and he said, oh, I hate productive struggle. It was awesome. I thought, my 3rd grader knows what this is. Productive struggle is that idea that things that are worth doing and accomplishing are going to be a little bit difficult. You got to work at it, right? Nobody becomes a professional basketball player by just showing up one day to a basketball court and saying, hey, I think I'll play basketball today. It doesn't work that way. You got to put work into it. Steph Curry shoots like how many shots every day? I remember reading about it. It's like an ungodly number. But these guys, a lot of kids think you just show up and do something like that. You don't. There's a lot of hard work that goes into this. So productive struggle is that idea that, hey, it's going to take a little bit of work. Learning isn't easy. It's an exercise for your brain. You got to work it. You got to practice it. You got to stimulate it. Because if you're not learning. And so you want to keep that in mind. You want to make things engaging enough so that kids activate in it and not so easy that they're completely bored in it.